Okay, hi everyone. Uh, I am recording this as a way for us to catch up a little bit. We've been behind in class, and I thought I'd record this video to go over the last examples in our textbook and hopefully provide you guys with, something to go off of. I don't want to just skip this material, but we need to catch up somehow. So this is kind of the middle ground here. So I am going to go through example one, COVID-19. It's about where we left off in lecture, a little after page 133, and about COVID-19. Before we start, I want to clear something up. I'll mention in class as well, but I gave you the wrong numbers here in class. I somehow got the math wrong, so let me correct that for you guys. So this interval here was incorrectly stated as about 2.11 to 2 point something else. The actual confidence interval goes like this: 0.1939 to 0.2452. Okay, so all that really changes is just the number. It doesn't change our conclusion, doesn't change our interpretation, it just changes some numbers. So that's the good news. So just let me fix these things and make sure you adjust this in your work. A student was very generous to explain this to me that I got it wrong, so thank you. A couple students actually approached me about it. So forgive me for this. Part of the discrepancy is that 22% doesn't come out to a whole number when you multiply it by 1002, as evidenced about here. Notice these aren't whole numbers. When your calculator asks for a whole number and you can't give it exactly, what 22% is, you'll get slightly different results. Don't worry, on the exam, we will not give you problems that are up to disparity or discrepancy. If we do, we will be generous in the grading process. So do not panic about this or why it's a little bit different. Just go off of, if it's slightly like this, you round it down. If it's like this, you round it up. So typical rounding rules apply here. Okay, so again, this doesn't change our conclusion because the interval still does not contain the value that we found, the 25%, right? Our range does not extend. The value is not inside 19.39% to 24.52%. Now, it is closer, but closer only counts in horseshoes. It doesn't matter here. Close doesn't count. So again, is it reasonable to make this assertion? No, because 25% is outside this confidence interval. Okay. So the latter part of this, rounding out this example, it asks for an interpretation of the margin of error. So the margin of error goes like this. The margin of error has a formula, and that is the upper bound minus the lower bound, all divided by 2. Okay, so we know what the upper bound is. We found that. The upper bound is 0.2452, and the lower bound is 0.1939. And then we divide all that by 2. And then if you do that math in your calculator, you put parentheses around this and then divide it by 2. You will get 0.02565. Okay, so this is saying that at most, the difference between the proportion that we found, the sample proportion, and what we calculate, the confidence interval, the bounds of the confidence interval, are this value. What it also means is a pretty cool thing. It means that the confidence interval of the population proportion, we're 95% confident that it differs from 22% by at most this value. So let me write that down for you guys, and you'll see it. And remember, a lot of these sentences are just in the back of your book on page 279. So if you're wondering, where am I getting this, or where is it coming from, again, it's just in the back of your book. So don't panic. Okay, so it goes like this. I am 95% confident that the population proportion of adult Americans who personally knew someone with the novel coronavirus. So that's the parameter. Remember, this value that we found that we're writing here, proportion of adult Americans. So, excuse me, let me not do that. Let me do this in a different color. Let's try this. Adult Americans who personally knew someone with the novel coronavirus. That is just the parameter, the population value, the thing that we're interested in discovering about, we're talking about. So that value, that population proportion, differs from our point estimate, 0.22, by at most, the most it's going to be different from is the margin of error, 0.02565. Okay. So there's that, write that down, pause the video. That's the beauty of these things. You can go at your own pace. Okay. So the next example is a concussion example, and this has to do with, concussions. So let me read the example. According to the Aspen Institute, quote unquote, Project Play survey of coaches and participants in youth sports in the US, a 99% confidence interval for the percentage of tackle football coaches that have undergone concussion protocol training within the past 5 years is 36.3% to 41.3%. And there's actually a link for this. And so the first question is point estimate. And it says, what is the point estimate for the population proportion in this case? And, if you're savvy with algebra and have good number sense, this might be obvious to you. If, you're not super wizard at this stuff, that's totally fine. Let me explain. It's one, you might get it through this. You might see, oh yeah, that's simple. If you don't, that's super okay. Let me explain. So the point estimate remember, that's the middle of the confidence interval. And the point estimate is just p hat. Okay? The point estimate is p hat, the sample proportion. This value is just the upper bound plus the lower bound divided by 2. Now, similarly to the margin of error, it's not subtracted, it's added. Okay? What you're doing is you're finding the average between two numbers, and you're finding the middle value, the middle between 2 points, and that would be the center for the confidence interval, which is the point estimate. So if that doesn't make a whole lot of sense to you, no worries, don't trip, it's all good. We'll give you this formula, but don't be intimidated by this. It's relatively straightforward. So we know the upper bound is 41.3%, so that as a decimal is 0.413. And the lower bound is 36.3%. So we plus that 0.363. Divided by 2, make sure this would all be in parentheses if you're doing a calculator. This would give you 0.388 or 38.8%. Okay, simple, straightforward, just want to use the formula. The real trick here, because we'll give you that formula, is understanding that the point estimate, what they're asking for is just p hat, is the sample proportion. Okay, so they gave us this interval. They gave us this 99% confidence interval, and they're asking us to interpret it. Well, interpreting it is just the sentence that we have in the back of the book that is pretty standard, and we'll say it. It's going to be very long, so stick with me. But it's just a lot of writing. I am 99%, because that's our percent we were given, confident that the interval and the interval they gave us, 0.363 to 0.413, captures the, I'm going to abbreviate some things, the amount of room here, the population proportion of tackle football coaches who have undergone concussion protocol training, room training within 5 years. Okay. That's just saying, that we're 99% confident that this interval they gave us captures the true population proportion. And again, this right here, this right here, tackle football coaches who have undergone concussion protocol training within 5 years, that's the parameter of context. That's the thing we're interested in learning about. Okay. So, third and last, the NFL claims that due to its outreach efforts, at least 45% of youth tackle football coaches have undergone training recently. Does the interval support this claim? And so, the way you answer this question is similar to the politician question, is you look at the 45% and you say, okay, is this 45% inside of the confidence interval they gave us? And since the confidence interval was 0.363 to 0.413, well, 45% is bigger than the largest value in the confidence interval. It isn't contained inside the value range. So, no, it doesn't. No, it does not. Okay. It doesn't support this claim. And to elaborate further, give some context aside from yes or no answer, you would say 45% does not fall within the 99% confidence interval and is therefore unlikely to be true. Now, it's not impossible, right? And we talked about this, or at least, hopefully we all talked about this in your activity, is the idea that just because something is unlikely doesn't mean it's impossible. We don't often say impossible or possible in statistics. We say likely or unlikely. Is it possible? Yes. But is it likely? Absolutely not. It is not reasonable to make this assertion. Okay, last example, and then we'll be done. Binge drinking. A survey of 10,904 randomly selected US college students collected information on drinking behavior and alcohol-related problems. The researchers defined, quote unquote, frequent binge drinking as having 5 or more drinks in a row 3 or more times in the past 2 weeks. According to this definition, 2,486 students were classified as frequent binge drinkers. Use the PMACC or PMAC process to calculate and interpret a 90% confidence interval for the proportion of all college undergraduates who admit to frequent binge drinking. Okay, so PMAC, parameter, method, assumptions, calculate, communicate results. That's it. So this is kind of the algorithm or the step-by-step process that we're going to ask you to use for a lot of word problems. And pretty much, I think every word problem you'll be given, from this point on to through the final. So for parameter P, we start with the parameter. Well, they kind of gave us a softball here. They kind of said, they asked us in the question what to do, and they gave us the parameter. So proportion of all college undergraduates who admit to frequent binge drinking. So that is what our parameter is. It's the proportion of US college, I'm gonna run a room here, students, and I guess I should be really clear. Whoops. Go back. I should just use exactly what it says. Do that. College, excuse me. Undergrads who admit to frequent binge drinking. Okay. So that is the parameter, the population proportion. Okay. So next is identifying the method. Now, because we're at this point in the course, we're only going to be using one kind of method for the exam. So, this is why it's only one answer to this part of the question. But what we're saying here is a one sample, is instead of two, so one sample, and then Z interval, as opposed to a T interval or a Z test or a T test. And that'll come later. But just for now, one sample Z interval. That's the method. That's what you're going to use to answer this question. Okay, assumptions. And there's two. There's two assumptions. One has to do with biasness, right? Did the sample that was collected, was it biased? They asked their 10 closest friends. I say that every time. But, was it a fair shake at the population? Was it a good representation of the population? And so there's two ways to do this. Either have it be representative or have it just be random. Random is best. So in this case, it was randomly selected. So we're good to go there. Just write that down. And the other thing is the number of successes and number of failures. Okay, those are the two things we want to figure out. If those two things are 10 or bigger, greater than or equal to 10, at least 10 or more, then the sampling distribution of p hat is approximately normal. And we need this to do the problem. If this fails, we have to stop. We couldn't do the problem anymore. So we do the following. We do n times p, that's the number of successes, and then we do the failures, n times 1 minus p. Well, they gave us already the number of successes, didn't they? It said in the question, according to the definition, 2,486 students were classified as frequent binge drinkers. Well, that is our number of successes. So that's 2,486. That's bigger than or equal to 10. Good to go. Conversely, the number of failures would just be 8,418. And that is also greater than or equal to 10. Remember, these two numbers, if you added these two numbers up, you would get the 10,904. And you can check that, 6 plus 8 is 4, it's 14. Add them, 8 plus 1 would be 10, 0, 1. 4 plus 1 is 9. And then 8 plus 2 is 10. So 10,004. That would come out. Okay. So next is calculate. This is where you get your calculator out. You do one prop Z interval on either your Casio or Inspire or TI-84, whatever you have. And you get two things. One, you have p hat, which is 0.2280. And then the confidence interval that you'll get, and you might get a slightly different confidence interval because of there's some weird rounding things I've seen, but it should be these values. If it's very, very slightly off, in this case, it's totally okay. I saw two values for this. I had a 6 or a 7 for this last number here. If a 7, that's fine. If a 6, I'm not sure what's going on there, but different calculators give different answers. I'm not sure, but this is what I have. It should be very close to this. But your Z interval, 1 proportion Z interval should give you this. Okay. So you got the math done. You got all the other things done. You have the most important part, which is communication. It's the thing that matters for our discipline. So it's thankfully relatively simple. All we have to do is just write a sentence. And it's the same sentence we've said numerous times. And it goes like this. I am, however percent confident, and in this case, we're 90% confident. That's the 90% confidence interval that we made. Confident that the interval, and this is interval 0.2214 to 0.2346 captures the population, I'm going to abbreviate here again, proportion of, and we have to go back. We're going to go to our parameter. Population proportion of U.S. college undergrads who admit to frequent binge drinking. Population of U.S. undergrads who admit to frequent binge drinking. Whoops, there we go. Just enough, just enough. Okay. So that's really the whole process. There's not too much more to it. In the last part, the last page of the section, there's a helpful guide where it lists out how to do each of these different processes in the different calculators, TI-84, TI-Nspire, and Casio. Very helpful. This is also available in the back of your book, starting at page, I believe, like 236 and onward. You pick the appendix that corresponds to your kind of calculator. It has really good pictures. There's really good pictures and step-by-step processes. Obviously, you need help on any of this, you're welcome to come to my office hours or email me or whatever you need. But remember that X is the number of successes. N is sample size, and confidence level, C level, is confidence level. Okay, I hope this was helpful. If you have any questions or I've made any mistakes, feel free to email me, reach out to me. I am at your disposal. Thank you so much, and have a wonderful rest of whatever day you have. Take care.